Hello, this is the first actual video on my channel. I'm interested in electrical engineering and computers, so I want to try to build a few digital logic circuits and explain the diagrams and ideas behind them. I don't really have anything else to say, so I'm just going to get into it. So here you probably have one of the simplest gates that you can make, which is the NOT gate, represented by this symbol here. So as you can see from the truth table, what happens is it just flips the input. So input false, output true, output false. How it works is we have our transistor here and our LED, and both of them are connected to the ground. So when the transistor, when input A is not receiving power from the button, then the power simply goes here through the LED and to ground. However, once we press that button and put power into the transistor, then instead of going to the LED, it goes through the transistor and straight to ground. So a very short demonstration here. If I press the button, LED turns off. Don't press the button, LED stays on. So this is another very important circuit, the AND gate. As you can probably guess from the name, it'll only output true when both A and B are true. So as we can see from the truth table, if either A or B are false, so A and B are false, false, A is false, false, B is false, false, then it will output false, it'll be off. And it will only be true on if both A and B are also true. So a short demonstration of the circuit here. If I hit either one of these buttons individually, the LED won't turn on, but if I hit them both at the same time, it will. The way that it works is we have these two transistors here and here, and the LED is receiving power. So the only way that the LED can get to ground is if it can go through these two transistors, which means that both A and B have to be on so that the power can flow across the transistors into ground. If just one of them is on, then it won't be able to get to ground. But if both are on, through to the ground. A little side note, I know it says 2K for all these resistors, but to make the LED a little brighter, I dropped it down to 1K for this demonstration. Here we have an OR gate, which is represented by this symbol here. How it works is if either A or B is true, then the output is true, and if both are true, then the output is also true. The only scenario in which the output is false is if both A and B are false. So you can see here, if B is true, the output's true. If A is true, output's true. If they're both true, the output is true. You can see this where if I press one button, the LED turns on, and if I press both, the LED is also on. The way this circuit works is kind of similar to the AND gate, where you have the two transistors here. But in this case, you only need one transistor to be powered for the current to go to the ground. So if we're receiving input from B, then the current can go across this transistor here and to ground. And if we are receiving input from A, then it can go across this transistor and to ground. And if both, it'll go across both. So for this next circuit, we have the NAND gate, which is an inverted NAND gate. The symbol is here. And it's essentially the opposite of an AND gate, where it is true unless both A and B are true. And an AND gate is special because you can use it to build pretty much every other type of logic gate. A quick demonstration. As you can see, if neither button's pressed, then it's on. Pressing either button doesn't have an effect, but pressing both shuts the LED off. The way it works is that normally the power runs through this resistor, through the LED, and then back to ground, and that will give us the positive output. However, what happens if both these two transistors that are linked together receive power from our inputs A and B, then the electricity will take the path of least resistance and simply go through the transistors into ground. If just A or just B is pressed, then it won't be able to go through the transistors into ground. What I've built here is an exclusive OR gate. This is the symbol for it. And it's similar to a regular OR gate in that when both inputs are false, the output is false. And when either one input is true, then the output is also true. However, the difference comes in when both inputs are true, in which case the output will be false. So when I first saw the design in the drawing, I wasn't sure how they linked together or how the diagram actually worked and linked to the truth table. But I'm going to explain it here. So the design I have here is borrowed from Global Science Network. I've just slightly modified it to add the buttons to make it a little bit easier rather than taking out the resistors for input. But as you can see, if I press one button, then the output is true, the LED turns on. However, if I press both buttons at the same time, the output is false. And also, obviously, when they're both off, the output's false. Where both A and B are off. So the power isn't going to be able to flow through the resistor and across the LED to ground because it's not going to be able to flow across either of these transistors to the ground because they're not being powered by either input A or input B. First, when both A and B are on, then what happens is the current will go across these two transistors that are getting power from A and B, and it's not going to go to this transistor, so it won't be able to go from the LED over to this ground. Then, for these next two cases, when either A or B by themselves are on, then the power is able to go across the LED, across either one of these transistors, and to this ground, which will complete the circuit and turn the LED on. All right, thank you very much for watching. I hope you learned something. If you didn't, I guess that's kind of my fault, but hopefully I improved.